The purpose of the following video is to show you how to calculate an independent sample t-test in Excel. So make sure you have your Excel spreadsheet open and the directions in the Word document available so you can follow along and replicate what I do. As always, you're welcome to pause the video at any time to perform calculations or to catch up. Now, the first step we always do when opening a spreadsheet is to check the codebook and make sure that we understand how the variable was collected and how it was measured. So if we open up our spreadsheet here, we're going to see two columns of data. One which has a label that says many contacts, and then another one that says few contacts. But we want to know the context of this particular scenario and what the research question is. So we can always go down to the codebook and see just what these measures represent. And so the first one that says many contacts tells us the self-reported likelihood of finding a job in the field of study with many contacts. This is where 1 is highly unlikely and 7 is almost certain. The other one is with few contacts, but everything else is the same. It's still on this scale of highly unlikely to almost certainty. Now, if we hover over, we see those scaling as well. 1 is highly unlikely, again, 7 is almost certain. But let's take a look at our scenario here. Obviously, we're looking at getting a job, and we're talking about contacts here. So our scenario is going to tell us here that who you know matters. Employment statistics consistently demonstrate that the more professional contacts a person has, the more likely they are to get a job. So you would like to know if the number of contacts that students at Auburn University make while in school influence their perceptions on how likely they are to get a job after graduation. So in this case, we'll say that you decide to use the students from a statistics course to see if the previous research holds at Auburn University. You obtain a measure of students with few contacts and a measure of students with many contacts, and then ask them how likely they are to get a job following graduation. We have our 7-point scale, again from highly unlikely to 7, which is almost certain. And we're going to use an alpha of 0.1 to test a hypothesis. So again, alpha of 0.1, it's a type 1 error rate. We're giving ourselves a 10% chance that if we reject a null, if we say who you know matters, there's a 10% chance that we could be wrong with our results. Okay, so that's the context of our variables. We'll go back to our data here. Always also, the second thing you should be doing is to make sure that your tool pack is available. So remember to go up to the data tab, right? And then check and just make sure you have this data analysis tool pack. If it is not installed, remember there are directions in the lecture to help you get it installed. All right, so in this particular case, we're going to do an independent sample t-test. And the reason for that is because if we look at our independent variable, we have two levels, many contacts and few contacts. And so if we're looking at each particular participant or observation in this particular study, right, each person is either going to have few contacts or many contacts, but not both, right? They're going to be one group or the other, not both. And so our two samples are not dependent upon each other. They're independent of each other. Each observation, each value in this data set, regardless of what column it is, represents a different person or a different student. All right, and so that means that we have a between groups design. The samples are independent of each other. Therefore, we should be doing an independent sample t-test. If you're looking at the directions, you'll see that, again, we're going to do an independent sample t-test when we don't have any population information and when our samples are independent of each other, which we just talked about. Each observation is in one and only one level of that independent variable. Each student either has many contacts or they have few contacts. They're not in both of those groups. All right, so to do our independent sample t-test in Excel, we're first going to get our descriptive statistics for our two samples. We're going to need the means and standard deviations from those. Now you already know how to get your descriptive statistics, but obviously we'll walk through it here just really quick. So we'll go to our data analysis icon, go to descriptive statistics, we'll click OK. We'll input our range. And remember, I talked about how you can get your descriptives for all your variables at the same time if you highlight all the columns that have your data in it. So we have two columns here. We'll highlight both column A and B. We do have labels in the first row. So the very first row of the data set. So we're going to check that labels in the first row box. And then also we need our summary statistics. That's what's going to give us our measures of central tendency and measures of variability. Now we're going to put our output a few columns away from our data. We don't need to do any particular data manipulation here, but it's still good practice to keep your output away from your actual data. Okay, and so we have our two columns here. We have our many contacts and a mean for that, as well as a mean for few contacts. I'm just going to highlight those here. And then we also have our standard deviations, which we'll need to report as well. So I'll highlight those also. Now just looking at those means, it looks like when students have many contacts, they seem to be more confident that they're going to get a job after graduation than those that have fewer contacts. So a mean of 5.97 compared to a mean of 5.48. Now, of course, we don't know if this difference is at a greater than chance level, which is why we conduct the independent sample t-test. So we have our descriptive statistics. Let's go ahead and go down to step 2 in our directions. And so here we're going to use that same data analysis icon, use the tool pack to get our t-test for 2 samples assuming equal variance. So again, I'll go to my data tab, go to data analysis, and now I'm going to scroll down to where it says t-test 2 samples assuming equal variances. So notice there's 3 t-tests there. You want the middle one. We're not going to worry about unequal variances. That's something you can learn in a more advanced class. So the one that we want, and we don't want the paired, right, because we're not doing a paired sample t-test, so we want the 2 sample assuming equal variance option. So it's that middle t-test option. We'll click OK. All right, and you notice that we're going to need to put in our variables. Now I'm always in the habit of doing variable, the second column for variable 1 and then the first column for variable 2. And the reason why I do that is with a paired sample t-test, the order matters if it's time bound. We talked about that with the last statistical test. For an independent sample t-test, it actually doesn't matter, just as long as you're consistent in all of your calculations and your subtractions for your effect size and for your confidence interval. But just to keep things easy and simple for me to remember, if I always do column B minus column 1, then when it doesn't matter, it's covered. And when it does matter, I'm covered, right? And so it just makes sense to me to go column B and then column 1. But just realize it's independent sample t-test. It doesn't matter which column you put as variable 1 and which column you put as variable 2. All right, so variable 1 here, I'm going to select the column that has few contacts. That's column B. And my variable 2 range will be column A, which is for the level of many contacts. Now next, you're going to have this hypothesized mean difference. This is based on the null hypothesis. So in other words, if the number of contacts doesn't matter, then we would expect the mean of the likelihood of getting the job to be the same for both groups. And if they're the same, then you subtract them, you would get 0. So this is based on our null hypothesis. The hypothesized mean difference in this case is going to be 0. It'll always be 0 for the sake of this class. We do have labels in that first row, so we're going to check that labels box. And notice we do have an alpha box here, an alpha field for the type 1 error rate. And so if you remember from our code book, we wanted to give ourselves a 10% chance for an error, which is an alpha of 0.10. And then that's it, right? Then we just need to select our output range, which I'm just going to put right underneath my descriptive statistics. And I'll click OK. All right, and there's my output. Now I'll need a few things from this output. I will need to know the observations for later when I am calculating my standard error pool. So I'm going to need that. I'm obviously going to need my t statistic. In this case, it's a negative 1.63. That t statistic is based on the differences of the means of my sample. And I'm also going to need the critical value. So in this case, a critical value for a two-tailed test is a positive and negative 1.67. Just make sure you remember when it comes to an exam or an assignment that Excel will always give you the positive value. You need to remember when it's also negative. So if it's a two-tailed test, we have 2 tails, one in the positive direction, one in the negative direction. So it's always going to be a plus and minus whatever your critical value is. In this case, it's 1.67. Okay, so if we were to look at our t statistic and compare it to our critical value, so the positive negative 1.67, we would find that our t statistic of negative 1.63 would barely miss the criteria or the cutoff for our two-tailed critical value. So in this case, we would fail to reject the null hypothesis, but not by a whole lot, right? It's really, really close. Negative 1.63 compared to negative 1.67 is very, 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 very close. And so just missing it barely. All right, so in this case, we would fail to reject the null hypothesis. It appears we would say in this case, based on the hypothesis test, that the perceived likelihood of getting a job, depending on the number of contacts, doesn't matter, right? Whether you have few contacts or many contacts, the likelihood of getting a job, or at least your perception of the likelihood of getting a job, is the same across both groups for our students. All right, so that's the hypothesis test. It appears that there's no difference, right, between our two groups, between many contacts and few contacts, but we still need to get an effect size, still need to get a confidence interval. So those are going to be the next two steps that we need to accomplish here. So I'm just going to go down to our directions here and note that we already went through these steps to get our t-test, right? We went data analysis, t-test 2 samples assuming equal variance. We clicked OK. We inputted our range for our data, right? We indicated what the null hypothesis was when it came to hypothesized mean difference. We put our output someplace, we clicked OK, and we got our output there in our Excel. All right, so the next step is to get our effect size. So if we scroll down in our directions, we'll see how to calculate effect size here. The first thing we need to do is we need to get our pooled standard deviation. To get our pooled standard deviation, we're going to take the pooled variance and take the square root of it. So remember that to go from standard deviation to variance, we just square standard deviation. So if we have to square standard deviation to get pooled variance, then to go from pooled variance to standard deviation, we take the square root. And that's what we're going to do here. So our pooled variance is already in our output. I'll go ahead and highlight here. I'll put it in green just so it's a little bit different. And to the side here, I'm going to put our symbol for the standard deviation pooled, which is just SP. All right, to get that pooled standard deviation, we're going to take that pooled variance and we're going to take the square root of it. So I'm going to hit equals here. I'm going to click on my pooled variance number. It looks like it's 1.30 here. I'll do my shift 6, which will give me that up arrow, and then the value of 0.5, which is the square root. And then I'll go ahead and hit enter, and it looks like in this case my standard deviation pooled is 1.14. So to get the effect size, we're just going to take the means of each of our groups, right? So our effect size formula is down here. D equals the mean of our two groups. We'll subtract them and then divide by that standard deviation pooled that we just calculated. So I'm going to hit equals. I'll do my open parentheses. I'll take the mean of few contacts and I will subtract the mean for many contacts. I will close the parentheses and I will divide by that standard deviation pooled that we just calculated. Right, and then it looks like we get for the effect size a negative 0.42. If we're looking at our size of effects, a 0.42 is going to be closer to a moderate effect than it would be a small effect. So this looks like it's a moderate effect. So remember, moderate and large effects tells us something's going on at the individual person level. So overall, with the hypothesis test, right, we didn't conclude that there is any difference in perception when it comes to likelihood of getting a job, regardless if you had few or many contacts. But it looks like, and again, that's at the collective level, the group level, it looks like at the individual level, it looks like it does matter. So for any individual student, so not collectively, but any individual student, it appears that it does matter when it comes to the likelihood of getting a job based on the number of contacts. And so the reason why there's this discrepancy is likely because we didn't have enough statistical power. We only had 59 observations, right, in our overall data set. Had we collected, 100, we probably would have rejected the null over here and had a moderate effect. But because we didn't have enough statistical power, we weren't able to say that there was any difference. But the effect size still captures that difference at the individual level. So we can say individually, an individual student, the number of contacts matters, who they know matters, but collectively it may not, at least based on our particular analysis here. All right, so we have a moderate effect here, indicating at an individual level that the number of contacts seems to matter to the likelihood of getting a job. All right, so the next thing we need to get is our confidence interval. So if we're looking at our directions here, to get that confidence interval, we're going to need to get the standard error pooled. Right? And so we don't have that in our output, so we've got to calculate this. To get that standard error pooled, we're going to take that pooled variance again, and we're going to divide by the sample size of each of our groups, and we add that together. Once we have that, we then take the square root of that addition. So let's walk through this. I'll put up our symbol. It's S, then M, then P. That's the standard error pooled, or the standard error combined. We'll hit equals. I'll do an open parentheses. We're going to take this pooled variance again, so this 1.3 number, and we're going to divide by the number of observations in our first group. So in this case, few contacts, there are 29 values in there, so I'll divide by 29. We're then going to add again that pooled variance, but now we're going to divide it by the number of observations for many contacts. Once I have that, I'll go ahead and close my parentheses. All right, so the pooled variance divided by the number of observations for one of your groups plus the pooled variance divided by the number of observations for the other group. Once we have that numerator, we're going to go ahead and take the square root of that quantity. So we'll do our shift 6, that gives us the up arrow, and we'll do 0.5. All right, and then we'll go ahead and hit enter, and our standard error in this case looks like it's 0.30 once we do our rounding. All right, so 0.30 is our standard error. Once we have that standard error pooled, we then get our confidence interval. So we're going to get a 90% confidence interval here. Again, because if we have a 10% chance for an error, alpha is 0.1, then we have a 90% confidence. We're going to have a lower bound and then an upper bound. To get that lower bound, if we're looking at our formula down here, we're going to take the negative t critical value for a two-tailed test. We're going to multiply it by the standard error pooled, and then we're going to add the difference in the means of our sample. We're going to do the same thing for the upper bound, except we'll just use the positive two-tailed critical value in that calculation. So we're going to hit equals here. We'll put our negative. We'll click on our two-tailed critical value. We will then put our asterisk to tell Excel to multiply. We'll multiply it by that standard error we just calculated, and we're going to add the difference in our mean. So I'll do an open parentheses, take my mean for a few contacts, minus the mean for many contacts, and then close the parentheses. And I'll hit enter, and that is going to be my lower bound. It looks like it's a negative 0.98. All right, for the upper bound, we're going to do the same thing. So actually, I'm just going to copy my formula from above. If you do this, make sure after you copy it, hit